Hello and welcome, everybody, to Last Week in Quantum. I'm your host, Bill Roth, self-proclaimed Silicon Valley marketing genius. This is the show where we review the week's news in the world of quantum computing, its impacts on the world of cybersecurity, AI, and more. And with us to discuss this week, as always, is Brandon Dennis, Director of Operations, and special guest, QuSecure co-founder and CEO Dave Krauthamer. Welcome to you both.
Thanks, Dave.
Thanks, Bill.
So, lots of great articles this week. Let's start by talking to our experts. So, Brandon, tell me about article number one, kind of focused on the core elements of what people need to know around quantum computing.
Yeah, absolutely. I had some news come out of MIT last week. The summary is, in partnership with Accenture, MIT researchers have developed a framework to access the potential of classical versus quantum computing for problem solving. Dave, I wanted to get your thoughts. How will we still use classical computers in the age of quantum?
Yeah, great question, guys. And, classical computers do linear types of things really well, things that go from A to B to C, and they're very efficient. We've been using them for a long time, and they're very powerful at linear types of things. That's not going to change because if you think of the superset of problems, there's a bubble, and those are linear things. But there's also another big bubble that are nonlinear things that are highly multivariable that quantum computers are really good at. And think of it as, instead of balancing your checking account, which is a multi-step thing, calculating the weather flow, which is an infinite number of variables, or modeling your neural nets in your brain. So think of the classical computing largely as the front end to computing. Quantum computers and classical computers will work together, I believe, for a long time, because quantum computers are not good at linear types of things because they're an approximation. So it's a very symbiotic relationship, and you'll almost always see them together, where a classical computer is synthesizing results, and it's a very productive synthesis of capabilities.
Excellent. Thanks, Dave. And folks, while we're at it, remember to subscribe to our YouTube channel and stay up to date on all things quantum. You'll see that in the show notes. Our second article has to do with error-corrected quantum computers. And this is sort of an interesting topic. Tell us a little bit more about it, Brandon.
Yes, sir. Out of the quantuminsider.com, another data point for our Qubits scorecard. QEra Computing announced that they've unveiled an ambitious roadmap for error-corrected quantum computers. And the plan includes a series of advancements starting in 2024 and culminating in a system featuring 100 logical error-corrected qubits. We talk a lot about qubit counts on the podcast. Dave, can you tell us the significance of logical error-corrected qubits?
Sure. So when I started in the quantum field, we started the company about 4 years ago, people thought we were nuts. There would never be an error-corrected logical qubit, because what we're trying to do is deal with noise at the atomic layer, which is hard. I mean, it's a hard problem. So, people thought it's never going to happen. A lot of reputable physicists said you will never have an error-corrected qubit. It's physically impossible. And, now with quantum, we're trying to map out the world at an atomic layer. So the fact that we have a credible roadmap to an error-corrected array of qubits is really phenomenal. Remember, you need approximately 4,000 error-corrected qubits to crack RSA. So getting to 100, it's starting on that march. And, the idea is that once you start really getting to error-corrected qubits, you have the ability then to really extend that array out dramatically. So I'm super excited about it. What it is to me, it's like the start of the game. And that is, I've got a real qubit, not a 1,000,000 to 1 correlation, physical, logical, but I've got a real qubit that really works, and it's error corrected. And so I'm super excited about it.
Excellent. Our third article, Brandon, is actually a podcast, as I recall, and it talks about the quantum computing edge and some key considerations for that. Tell us a little bit more about that.
Yeah, we're going to switch over to some DoD topics here. So shout out to Aerospace Advantage Podcast. In last week's episode, experts discussed the importance of quantum computing in defense innovation. Quantum developments can address critical vulnerabilities and capability gaps in timing, navigation, sensing, and radio frequency reception. However, realizing these breakthroughs requires investment and stewardship from the Department of Defense. So, Dave, considering our dependence on current sensing platforms, what obstacles do you foresee when upgrading in the future, particularly with the emergence of quantum computers?
Yeah, I'm super excited about sensing. Because think about sensing now. Like, you have LiDAR on your car, and it basically shines a beam out and gets a signal back to try and understand the environment. Now, we've made significant progress there in sensing, but with quantum sensing, you're sensing your environment at the atomic layer. So the level of granularity is infinitely better than what we have now. And so as we move towards this ability to sense our environment or the world around us at a much more finite level, the capabilities are quite astounding. Like, clearly there's a lot of upgrade in this cycle, and we're going to have to do a lot of work to swap out these systems, most critical systems first. The other thing is the systems today are vulnerable to attack. And as we move to these new technologies, we'll be able to kind of roll out post-quantum, this crypto agility that QuSecure focuses on. But I'm really, really stoked about the sensing market. I think it's super powerful, and it's going to give us these capabilities that we couldn't even imagine of in the past.
All right. Well, those 3 articles will exist. You can find all the links to those articles in our show notes. And if you want weekly quantum updates, join our mailing list by visiting our LinkedIn page, QuSecure on LinkedIn. That's all for today's show. I'm your host, Bill Roth. And with us today has been Brandon Dennis, Director of Operations, and special guest Dave Krauthamer, co-founder and CEO. We'll see you next week on Last Week in Quantum.